Hi guys! In this video I will explain you Beresenham's circle drawing algorithm. As we know, in the circle any point from the origin to the point on circumference is the same, equals to the radius. In this video we will use this symmetrical position in circle in order to calculate Beresenham's circle drawing algorithm. There are 4 symmetrical quadrants and 8 octants in the circle. At every quadrant there are 2 octants. This is one octant. Yes, octant 1, octant 2, octant 3, octant 4, octant 5, octant 6, octant 7, and finally octant 8. In order to draw a circle in the computer screen, all we need is to calculate the first octant. Based on the symmetrical position in the circle, we can calculate the rest of the 7 octants according to the values on the first octant. We will start the calculation from 0 r point, where x will be 0, y will be r. In the Beresenham circle drawing algorithm, the value of x will always change with unit interval. Y coordinates will be decided by algorithm. So y can be whether yk or yk minus 1. And the calculation of the first octave will be finished in this point, where x will be more than and equal y. Computer screens consist of many pixels. In order to draw any type of line on screen, computer have to choose pixels. In this situation, one of these pixels should be chosen, upper or lower pixel. By using Beresenham circle drawing algorithm, computer will decide the right pixel. At every iteration, x coordinate will increase by 1, because the curve of the circle is growing at the direction of x coordinates. So x coordinate will change with unit interval. Y coordinate can equal to the previous pixel or can decrease by 1. So yk plus 1 will be yk or yk minus 1. Now let's see how it works. Beresenham's algorithm will calculate these distances: the distance from the curve to the upper pixel f of n, the distance from the lower pixel to the curve f of s. We have already previously plotted point x, y. According to the previously plotted point, we can show upper pixel as xk plus 1 and yk, the lower pixel as xk plus 1, yk minus 1. Now let's analyze the derivation of the algorithm. Let's write down the circle equation, which center lies at the origin and radius is r. X squared plus y squared equal r squared. The function of f of x comma y will be x squared plus y squared minus r squared. This is our initial equations that will help us to calculate the further operations. Now, based on these equations, we will calculate f of n and f of s functions. We have already written that the coordinates of f of n will be xk plus 1 yk, the coordinates of f of s will be xk plus 1 comma yk minus 1. Now we will replace these coordinates in the original equation. We will find out these functions. F of n will be xk plus 1 square plus yk square minus r square. So x will be replaced with xk plus 1, y will be replaced with yk. F of s equals xk plus 1 square plus yk minus 1 square minus r square. Here we will replace x with xk plus 1 and we will replace y with yk minus 1. According to the circle equation, we have already found these 2 functions. Now computer will choose one of these 2 selections to plot. The error in f of n and f of s will be calculated now. Finally, the distance that gives less error will be selected. We need to find less error. decision parameter will decide the east point or the southeast point has less error. We will show decision parameter as di, and di equals f of n plus f of s. Now we have to analyze two important conditions. First one, if a point is inside of the circle, then the distance from the circle will be negative. The second condition, if a point is outside of the circle, then the distance from the circle will be positive. As we know, f of n is the distance from the circle to outside point. So f of n will always be positive. On the other hand, f of s demonstrates the distance from the inside point to the circle. It means f of s will always be negative. After calculating the decision parameter, we will see our conditions. If DE is less than and equal to 0, it means that southeast point f of s is greater than east point f of n. It means f of s has greater error. We said that less error will be selected. In this case, f of n will be selected. And the coordinates of f of n are xk plus 1 yk. On the other hand, if d is more than 0, east point is dominant and it has greater error than southeast point. In this case, f of s will be selected. The coordinates of f of s are xk plus 1 yk minus 1. So if DE is less than or equal 0, the next coordinates will be xk plus 1 and yk. If DE is more than 0, the next coordinates will be xk plus 1 yk minus 1. Now it's time to calculate initial decision parameter. Initial decision parameter equals f of n plus f of s. And in this calculation, we will replace f of n and f of s with above written equations. So decision parameter, initial decision parameter equals xk plus 1 square plus yk square minus r square. This is the value of f of n. And plus xk plus 1 square plus yk minus 1 square minus r square. This is the value of f of s. We're going to simplify this equation. So we'll get di equals 2xk plus 1 square plus yk square plus yk minus 1 square minus 2r square. This is the value of initial decision parameter. Now we're going to calculate the next decision parameter. In this case, we will replace all xk's with xk plus 1 and all yk's with yk plus 1. So we're getting xk, 2xk plus 1. Yes, we're writing the last version. 2xk plus 1 square plus yk plus 1 square plus yk plus 1 minus 1 square and minus 2r square. As we know, x coordinate will always change with unit intervals, so we can replace all xk plus 1s with xk plus 1 because we already know this, but we cannot replace yk plus 1 with anything because we don't know that. After simplification, we will get for next decision parameter 2xk plus 2 square plus yk plus 1 minus yk plus 1 square plus yk plus 1 minus 1 square minus 2r square. This is the equation for next decision parameter. Now we're going to find the difference between next decision parameter and initial decision parameter. We will subtract from the next decision parameter the initial decision parameter. So we will get 2xk plus 2 square minus xk plus 1 square plus yk plus 1 square minus yk square plus yk plus 1 minus 1 square minus yk minus 1 square. And 2r squares will be cancelled out because minus 2r squares plus 2r square will be 0. We continue to simplify the equation until we get the simple equation at the end. So we get 2xk plus 2 plus xk plus 1 xk plus 2 minus xk minus 1. This is the simplification formula of a square minus b square. It will equals to a minus b times a plus b. I'm using this formula in order to simplify my equation. I hope you understand this simple mathematical simplification process. Then plus yk plus 1 minus plus yk and yk plus 1 minus yk plus yk plus 1 minus 1 plus yk minus 1 times yk plus 1 minus 1 minus yk plus 1. I'm going to simplify again. So I will get 2 times 2xk plus 3 times 1 because xk's will be cancelled out and 2 minus 1 will be 1, so I don't need to write times 1. Then I will get there is no simplification process here. I will write as it is. So I will get yk plus 1 plus yk times yk plus 1 minus yk. The third operation, I will write yk plus 1 plus yk minus 2, and here yk plus 1 minus yk minus 1 and plus 1 will be cancelled out. So this is the end of the simplification process. I can write this last version equation for the next decision parameter. Next decision parameter equals to initial decision parameter plus 2xk plus 3 plus yk plus 1 plus yk times yk plus 1 minus yk plus yk plus 1 plus yk minus 2 times yk plus 1 minus yk. This is the formula for the next decision parameter. Now we're going to look at the conditions. If di is less than and equals 0, our next coordinates will be xk plus 1 and yk, as we already written above. So we will replace all xk plus 1s with xk plus 1 and all yk plus 1 with yk. We will get, for our first case, we will get di plus 1 equals di plus 2 times 2xk plus 3 plus yk because we replaced yk plus 1 with yk, times yk minus yk plus yk minus 2 times yk minus yk. As you see, we replaced all yk plus 1 with yk. So we got 0 and 0, and finally we get di plus 2 times 2x plus 3. So in the case of di is less than or equals 0, the next decision parameter will be di plus 4x plus 6. Now let's look at the second condition. In the second case, if di is more than 0, the next coordinates will be xk plus 1, yk minus 1. In this case, we will replace all yk plus 1s with yk minus 1. So the next decision parameter will be di plus 2 times 2xk plus 3 plus yk minus 1 plus yk, because we will replace all yk plus 1s with yk minus 1. Yk minus 1 plus yk times yk minus 1 minus yk, plus yk minus 1 plus yk minus 2 times yk minus 1 minus yk. Now we're going to simplify this process again. Then we will get, for the next decision parameter, di plus 1 equals di plus 4xk plus 6. In the second equation, yks will be cancelled out. We have minus 1 here, minus 1 times 2yk minus 1. So we will get minus 2yk plus 1. In the third operation, again, yks will be cancelled out. We will get minus 1 here, minus 1 times 2yk minus 3. So we will get minus 2yk plus 3. As a result, the next decision parameter will be di plus 4xk minus 4yk plus 10. This is the final equation for the next decision parameter in the case of di is more than 0. Now let's find out how to calculate the initial decision parameter. We already know that at the initial point xk will be 0 and yk will be r, the radius of the circle. Now we're going to write down our main decision parameter equation as we have written in the previous calculations. So di equals 2 xk plus 1 square plus yk square plus yk minus 1 square minus 2r square. So here in this equation we will replace xk's with 0 and yk's with r. As a result, we will get 2 plus r square plus r minus 1 square minus 2r square. We will get 2 plus r square minus 2r plus 1 minus 2r square, and 2r squares will be cancelled out. We will get 3 minus 2r. Initial decision parameter d0 equals 3 minus 2r. So this is the end of my explanation. Here you can see all the necessary equations of the Beresenham circle drawing algorithm. I tried to explain you the derivation of these formulas, but as a result you just can learn these formulas in order to apply Beresenham's algorithm. Hope you enjoyed the video and the derivation of Beresenham's circle drawing algorithm made sense for you. Thank you so much for watching the video. Wish you the best in your exam.